In 40 years of turning wrenches, I have watched a lot of trucks come through shop doors. I have seen timing chains jump, head gaskets blow, and transmissions turn themselves into expensive gravel. But I have never seen anything like what I am seeing now. The mechanics I respect, the ones with 40 years of calluses and a shop full of their own tools, are not buying new trucks, not one of them. And when you ask them why, they do not rant. They just walk you under the hood and start pointing. What they show you will change how you think about every truck payment you have ever made. Let me tell you what they know that the dealership is hoping you never find out. The business model is simple. Automakers used to make money selling you a truck. Now they make money selling you a truck that breaks on a schedule they designed. Every engineering decision made in the last 15 years, every turbocharger, every 10-speed transmission, every diesel exhaust fluid tank bolted under your bed was made in a boardroom, not an engineering lab. And every one of those decisions transferred cost from the manufacturer's balance sheet directly into your repair bill. They call it advanced powertrain technology. We call it a $40,000 countdown timer. Here is the economics. Your grandfather financed a truck for 3 years. You are financing yours for 84 months, 7 years of payments on a vehicle that the manufacturer engineered to deliver its first catastrophic failure at 80,000 miles. By the time the transmission goes, you still owe $30,000 on a truck that just became a liability. You are not building equity. You are renting depreciation on a machine designed to expire inside the warranty window and fail spectacularly just after it closes. The average new full-size truck now stickers above $60,000. The average repair bill for a failed diesel emission system runs between $3,000 and $8,000. A failed high-pressure fuel pump on a modern diesel will cost you $10,000 to $20,000. And we will get to exactly why in a moment. A 10-speed automatic transmission rebuild runs $6,000 to $12,000. Stack 2 of those failures together and you have spent more on repairs than some people paid for their first house. That is not bad luck. That is the business model. They call it fuel efficiency engineering. We call it transferring manufacturing savings into your repair account. But the business model is only half the problem. The engineering under the hood has been designed to expire. Let us open it up. Start with the diesel. In 2010, the EPA mandated that on-road heavy-duty diesel truck manufacturers add a selective catalytic reduction system to their exhaust. That system requires diesel exhaust fluid, urea solution, injected into the exhaust stream to reduce nitrogen oxide emissions. They call this system clean diesel technology. Here is what it actually is. A plastic and steel DEF injector assembly mounted under your truck bed, surrounded by heat, road debris, and winter weather. Urea crystallizes in cold temperatures. It clogs the injector. It contaminates the sensors. And when those sensors trigger a fault code, your truck goes into limp mode. Sudden catastrophic power loss. Sometimes on the highway, sometimes while towing, sometimes at the worst possible moment. The repair is not cleaning the injector. The repair is replacing the entire exhaust section, catalyst, injector assembly, sensors, and all. $3,000 to $8,000 depending on how far the damage is spread. And every calibration requires dealer proprietary software. You cannot do this repair in your own driveway. Before the emissions mandates took hold, diesel trucks ran a simple exhaust gas recirculation system, cast iron manifolds, mechanical components, rebuildable at any shop in America. Those pre-mandate diesel trucks are routinely crossing 500,000 miles with sub-$1,000 repairs. The DEF system, by contrast, typically fails between 100,000 and 150,000 miles. The manufacturer saves $50 per unit in EPA emissions credit offset. You pay $8,000 when it fails. That is not engineering. That is arithmetic. Now look deeper into the engine bay. Find the high-pressure fuel pump. On modern diesel trucks, every Ford Power Stroke and every GM Duramax built after 2011 and every Ram equipped with a common rail injection system after 2018. That pump is a Bosch CP 4.2. It pressurizes fuel to 30,000 pounds per square inch to meet the tight atomization tolerances that emissions compliance demands. Before those transitions, those same trucks ran a Bosch CP3 pump, a robust radial piston design. rated for 500,000 miles of reliable service. The CP 4.2 is not the CP3. It is a compact aluminum unit with roller lifters designed for space efficiency and cost reduction, not durability. Ultra-low sulfur diesel, the only fuel available at every pump in America, does not provide adequate lubrication for the CP 4.2's internal tolerances. The pump wears, metal shavings migrate into the high-pressure fuel rail. Those shavings travel downstream into every injector in the engine. The entire fuel system, pump, rails, injectors, fuel injection control module, is contaminated simultaneously. There is no partial repair. You replace everything. $10,000 to $20,000. Eric O. at South Main Auto, one of the most respected diagnostic technicians working on camera today, has called the CP 4.2 a grenade. That is exactly what it is. A grenade with an 80,000 to 150,000 mile fuse. The class action lawyers agree. A Stellantis CP4 lawsuit involving Ram trucks is a matter of public record, tied to an NHTSA recall affecting over 200,000 trucks and directing dealers to reinstall the CP3 in its place. General Motors settled a parallel Duramax CP4 lawsuit, Chapman versus General Motors in 2025 for $50 million. When manufacturers are writing 8-figure settlement checks over a fuel pump design, that is not a defect, that is a documented engineering crime. The CP3 pump that preceded it has no equivalent lawsuit, no equivalent NHTSA complaint density, no equivalent catastrophic failure mode, because it was built to last, not built to comply. Now move to the transmission tunnel. In 2017, Ford introduced the 10R80 10-speed automatic into the F-150. GM followed with the 10L90, first in the Camaro ZL1, then in the Silverado. 6 speeds became 10 speeds in short order, and the industry called it progress. Here is what actually changed. 6 clutch packs became 10. A simple hydraulic valve body became a solenoid-controlled computer network. A transmission that a skilled rebuilder could disassemble on a bench with hand tools became a unit requiring $5,000 proprietary diagnostic equipment just to read the fault codes accurately. The synthetic fiber friction material in the clutch packs and replacing the durable metal clutches of older 4-speed and 6-speed units began wearing under the cold start shift logic that hunts aggressively between 10 ratios looking for the optimal fuel economy number. The result is shudder, slipping, harsh engagement, eventually no drive condition. Typically between 60,000 and 100,000 miles, right at the edge of the powertrain warranty. A full rebuild runs $6,000 to $12,000. O'Connor versus Ford Motor Company, filed in the Northern District of Illinois, is working through the courts over exactly this failure pattern. Your grandfather's 4-speed automatic, the 4L80E in a Chevy, the 4-speed heavy-duty in a Ford, ran for 400,000 miles. Rebuilds cost $2,500. Parts were on the shelf at every transmission shop in America. The 10-speed saves the manufacturer $100 per unit in manufacturing cost and delivers 2 to 3 miles per gallon of fuel economy improvement on the EPA test cycle. You pay $12,000 when it fails at 80,000 miles. That is the only math that matters. And then there is the body. In 2015, Ford switched the F-150 to a riveted military-grade aluminum cab and bed. The weight savings were real. Roughly 700 pounds. The problem is also real. Steel fasteners in aluminum panels create galvanic corrosion at every rivet joint. Thermal cycling between -40 and 140 degrees Fahrenheit loosens rivets and propagates stress cracks at wheel wells and door hinges. A steel truck with surface rust is ugly. An aluminum truck with structural rivet failure is a $5,000 repair that most independent shops cannot legally perform. Because aluminum welding and riveting requires specialized certification and equipment. The first generation of aluminum F-150s is now hitting 10 years old. The failure curve is just beginning to rise. Now here is what happens when you try to fix any of this yourself. The DEF system calibration after a component replacement, dealer proprietary software only. the TCM flash for a 10-speed transmission replacement. Ford and GM do not release that software to independent shops. A replacement oxygen sensor on a post-2018 truck. The ECU pairs the sensor to the vehicle at the factory. Put in an aftermarket unit and the system throws a fault code that only the dealer's laptop can clear. The John Deere farmers already lost this fight. They could not repair their own equipment on their own land without a dealer service appointment. Automakers watched that outcome and copied the playbook directly. This is not accidental complexity, this is engineered dependency. Every software lock, every serialized component, every proprietary calibration procedure is a toll booth between you and your own property. So what do real mechanics drive? Let me tell you exactly. The 5.9-liter 12-valve Cummins, 1994 through 1998, Dodge Ram 2500 and 3500, mechanical injection pump, no electronics on the fuel system, no DEF tank, no emissions modules, cast iron block, cast iron head, mechanical P7000 injection pump that any diesel shop on the continent can rebuild from a parts book. These engines are crossing 600,000 miles in documented farm and fleet use. The 12-valve is not a legend because of marketing. It is a legend because it was engineered to survive, not to comply. The 7.3-liter Power Stroke IDI in the 1994 through 2003 7.3 direct injection Ford F-250 and F-350. The 7.3 is the most reliable diesel Ford ever put in a truck. Cast iron block, HEUI injection on the direct injection versions, no CP4 grenade, no DEF system, glow plug issues at high mileage, manageable, cheap, fixable in a driveway. 300,000 to 500,000 miles is not exceptional for a well-maintained 7.3. It is normal. The Bosch CP3 equipped 6.7-liter Cummins in Ram trucks from 2007 through 2018 is the last generation of the heavy Cummins before the CP4 arrived in 2019. Still, DEF equipped, a limitation, but without the fuel pump death sentence. If you are buying a modern Cummins, this entire generation is your target window. For gas trucks, the GM 5.3-liter Vortec LS series is the standard. 1999 through 2013, Silverado and Sierra. The early iron block versions are the ones to seek out. Sequential fuel injection, no turbocharger, no cylinder deactivation oil consumption on the earlier generations. Every part available at AutoZone. Every independent mechanic in America can rebuild one. 300,000 miles is not a stretch goal. It is the expected outcome with maintenance. The Toyota 4.0-liter 1 GRF EV6 in the 2003 through 2009 fourth generation 4Runner is the foreign benchmark. Mechanics call it the Anvil, aluminum block with cast iron liners, forged steel crankshaft, chain-driven DOHC with bulletproof timing chain geometry, no turbo, no DEF, no subscription features, well-maintained examples routinely exceed 250,000 miles before the first significant internal repair. When you buy any of these, know what to inspect. Pull the transmission dipstick. If the truck does not have one, walk away. Check the frame behind the rear axle for rust perforation, especially on northern trucks. On diesel trucks, pull the fuel filter and look for metal contamination. On any GM truck, check the valve covers and intake manifold for oil accumulation from the positive crankcase ventilation system. Look at the tire date codes, look at the maintenance records, and then do the only math that matters. $15,000 for a proven pre-mandate platform, 0 software locks, and a repair bill universe that tops out at $2,000 versus $80,000 financed over 7 years for a truck that will strand you at 100,000 miles and demand dealer permission to fix itself. Here is the verdict. Stop buying the technology. Start buying the engineering. Stop trusting the EPA fuel economy sticker. Start reading the NHTSA complaint database. Stop financing your way into digital dependency. Start owning a machine that a wrench can fix. The most reliable truck in America in 2026 was not built in 2026. It was built before the mandate that made reliability illegal. Buy the machine they stopped making. Drive it until the wheels fall off. And when they do, put new wheels on.